Let's get started. Okay, so let's grab, let's go to the community edition and just grab the latest. Report. Okay, so it's about 3.8 MB now. Yeah, I hope it stays under 6 after the semester is over. Okay. So we have 32 notebooks now. So last time we were looking at the tweet collector and how to set up a Spark streaming context and plug into Twitter and collect tweets based on a set of user IDs that you're interested in, as well as some other strings of interest. So this is a track and follow one. So what I thought we could maybe, and then I sort of introduced you to all these tweet transmission trees and various data frames that immediately allow you to start doing various SQL queries at scale on the Twitter data you're collecting. Now, what we could, for example, do next is setting up a proper streaming job where we're collecting, but then as the data is coming in these discrete RDDs, we can apply various windowing functions. Okay, so we can actually do live queries. For example, we could could just get all the hashtags in each tweet and then simply count the number of hashtags and report the top 10 hashtags in every 5 seconds. Okay, that's just a demonstration of some of the things you could do. So let's maybe attach this to some cluster. And so this is our notebook that has various Twitter4j imports and the extended Twitter utils class. Not really sure we need this actually. And then you wanted to get your own Twitter credentials here. So as I know you have gotten your Twitter credentials. Okay, so who has the Twitter credentials already? Okay, good. Because I'm not going to evaluate my own thing now, just because my keys are somewhere else. So anyway, if you run this, or you should get your own Twitter credentials, then here I'm just setting up an output directory and then a slide interval. So this is simply to recompute the top hashtags every capital N seconds. So I'm just setting N to be 1000 milliseconds or 1 second. Okay, so you can play around with this actually. Window length, So maybe those of you who have Twitter, maybe you can play around with this as things are working. So the window length is simply, you know, how long am I going to be collecting my, what's going to be my window length on the streaming job, right? So this is, I'm just setting it to be 5 seconds, and this is just some timeout job length. So if nothing happens for 100 seconds, you just stop it. Yeah, here actually I'm using it also to stop the job after 100 seconds have passed. Okay, so I'm only going to be collecting the top hashtags every 5 seconds, starting from, and doing this 100 times. So then you want to make sure there is no streaming context running, because then you only have one streaming context in the small shard like this. I'm just cleaning my directory to make sure it's empty before I start collecting. So here, let me slightly make this bigger. So the main new idea is, so we want the second value ordering, because what we're going to do is create a tuple like this, once we do the count. So we'll have the hashtag as a string, and the number of times that hashtag occurs in that 1 second is an int. But then what we want to do is rank the hashtags by the int, the count. So we just have to do some second value ordering. So we just create a little object which extends ordering. So we import math ordering, and we're defining this ordering to be applied on this string int tuple, and we simply define the compare method for this. So we have two things, a and b, string int and string int, and we just say a dot underscore 2, which is the second element, compared to b dot underscore 2. And this compare will just be the integer compare, which will be the default, less than. So that's the only other thing. And this function, you should remember from before, we had this streaming context. So this thing returns a streaming context, creating func, and we simply start with the Spark streaming context, with which needs two parameters. So the Spark context is the parameter for the streaming context, as well as the slide interval. So this is going to be, slide interval was 5 seconds, right? What was it? 1 second. So then, I have my OAuth authorization credentials from my keys I put in, and my extended Twitter utils method we pulled in. So we use that, the create stream method in there. We pass in SSE and auth, streaming context and our authorization credentials, and we create our Twitter stream that way. Now, the new thing is we have this hashtag stream, which is nothing but the Twitter stream, and we're simply doing a map. So we're taking every element in the stream, okay, and doing this get text method. So this is just, we'll just simply return the text in the tweet, okay. And then we are simply doing a flat map. So flat map will simply take, so what we're going to do is take every text in the tweet and split it by white space, and then flat map that. And then we are filtering by all the words that start with a hash. So that's it. We're just getting all the hashtags. Okay. So once we get our tweet stream converted to hashtag stream, we just do this windowed hashtag count stream. Okay, so what is this? This takes the hashtag stream, maps every hashtag to the tuple hashtag comma 1, integer 1. And then I use this function. This is the main thing. This is reduce by key and window. So I'm interested in the key, which is going to be my, my hashtag here. And then the window is, of course, the window we set in the streaming context. So reduce by key and window. is a reduce operation, it's an action. So that thing will have, we have to say what happens to a pair. So we just say the pair will be, the value, what happens to the value. So values are integers, so I'm just saying x and y are integers, just add them. So that's just word count. Hashtag count, okay? So and then, but reduced by key in window has other parameters, window length and slide interval. We just pass them in. So is that clear? I mean, this is just going back to the first week's reduced by key, except now we have and window.
So how would this work? We will now have multiple windows in this.
Yeah, so it'll be doing it on the current window, right? So because your Spark streaming context is giving you a sliding interval, and so it'll just apply it to that. So it'll be.
So how do you move the window? Does it move by itself? Or?
Yeah, okay. Because we yeah, exactly, because it's a discrete RDD under the hood anyway, and the Spark streaming context has all of that taken care of. So we're now just saying do something to this.
But this process is after downloading the tweets. But this is
no, this is live. So this is as the tweets are coming in, right?
But then tweet has this, like, they don't give you to download multiple, like at the same time, many tweets. Then how do you overcome this problem?
Well, we just did it last week, right? We downloaded like hundreds of tweets, and
yeah, but if you have this like parallel like downloading, then you are hitting the tweet server multiple times.
No, you're using the Twitter streaming API, right? The Twitter streaming API. I don't know. There's a lot of docs, right? So I don't know if you had a chance to look at the Twitter streaming API documents. So what we're doing, okay, so let's maybe step back. So, because the next notebook is empty for a reason. So I want to like decide what you guys want to do. Okay, so what did we do in this? So this is even more complicated, right? So let's just look at this one. This one maybe. So what are we? So we have a lot here, but okay. So once I had set up the sliding interval and the streaming context, streaming API. So this is basically the breakdown of it, right? Even before I abstracted away into, so I was just doing piece by piece like boilerplate. So, I mean, the first thing you need to understand is the Twitter streaming API. So Twitter developer docs. Right. Okay, so let's look at, so I don't know, have you looked at this? So I mean, anybody can collect up to 1% of all the tweets in the planet. So of course you can get more than one tweet if you get this.
I think it depends upon the interval how you hit the server. Like you need to wait for a few minutes, a few seconds, like before you hit it again. But if you are doing parallelizing, like you are doing multiple times, then I think that would be a problem.
So are you saying, so okay, first of all, we agree that anyone can download tweets, right? More than, in 1 second. We just did it last week, right? People were getting, what is it? I think it's like something between 30 and 60 to 70 tweets per minute is the average. Okay, so I'm just doing a hashtag count on that. I don't really understand. I mean, the whole issue of using multiple Twitter credentials and using different IP addresses and hitting the Twitter to get more than what one person is allowed to, that's a whole different problem. I don't know if that's legal. Is that what you're talking about? Okay.
I thought like when you are doing parallel process at the same time, you are hitting a server from your IP address multiple times.
Oh, no, sorry, no. There's nothing parallel like that here. So we just are getting this one streaming call, right? We just ask our streaming API to give us the free 1% of tweets. And in that, we just have these Spark streaming context built with some window. So it just basically discretizes, it produces discrete RDDs for us. And what's in a discrete RDD? A whole bunch of tweets. That's it. And all I'm doing now is just mapping each tweet to the text, to the hashtag, count the hashtag, and order it and report it. That's all. There's nothing more. This is just sequential. So, I mean, it should work. So, yeah, so let's see. I can, let's just do this. So I just didn't want to bring this up. So I'm just going back to the academic chart quickly. And, okay, so here my keys are loaded. So go, just making sure there's nothing there. And my directory is already empty, so it should be, it's not empty. So here's, so actually, yeah, in case something crazy happens, because always the demo gods could be, so this is what I did just this morning, okay? So 7:20 a.m. today, I was just looking at it, and this was every second. I was counting. Jesus and Muhammad were on the top. Allah too. I have no idea. This is one count. Okay. So anyway, we can just do the slide right now. Okay, so I think I was explaining all of this. And right here, all I'm doing is for each window, now I'm doing my for each RDD method. I'm simply taking my hashtag count RDD, which is what's going to come out of here basically, and then I'm simply doing my second value ordering, and on the top 10, and I'm simply reporting this. So what I'm using dbutils fsput. This is a Databricks specific method, and I'm simply putting it in output directory, and so now ordering, yeah, so that's it. So I'm incrementing it. Now let's start the streaming context, and so that sets it up. So let me start and do this 100 times. So okay, so nothing happened in those seconds because it was setting up. So now I have, I don't know, mental health awareness day. No. nature photography. Okay, so I mean, you can play around and change the seconds. I'm just doing it very quickly just to show the lower end. You can set it up for 1 minute and count the top hashtags for a bit longer or whatever. Okay, so I could just stop this. So maybe hundreds. Yeah, there's some strange parsing things going on. It's pulling HTMLs. Not sure. Halloween, end of line, some HTML. So this should stop after 99, I believe. Yeah. So then you don't really have to hit this, but this is just a safety. And then you can just look at what's in your output directory. So you should have something like this. So we just wrote, top hashtags underscore 0 and so on. And you can just look at, I don't know, what's in the 11th one. Okay, so let's try one other thing. 20, I'll change a little bit. So let's say the slide interval is, let's make it slightly more interesting, like 10 seconds. And let's say the window length is, how about 25 seconds or maybe 30 seconds? Okay, so half a minute. And I guess maybe I'll be a bit impatient and say, just assume like 20. Just clear everything again. Let's see if this works. Okay, so in context, let me stop this. So I think I know what you're worried about. So when you use REST API, you have like rate limits and things like that. So when you hit it too hard, faster than what it's allowed, then it'll time out or reject your request. That's what you mean?
Yeah.
Yeah. So I have like we could totally get into it. I have an empty notebook. To get into, because if people are interested in interactive experimental design in Twitter, then you may want to use a combination of the streaming API where things just come at you. You have some control on how you zoom in, of course. But then you can also take the output of the results from the streaming API and then start using the REST, or representational state transfer API, to ask specific questions. So, for example, I'll come back to that in a minute. We can find out the timelines, the histories of each user of interest, and start diving into their historical timelines and see who they retweeted or who influences them, and do a breadth first expansion by a combination of REST and streaming. Right? So that way you can sort of study populations of interest or people you want to sell stuff to. And this happens all the time on Twitter. That's kind of one of the main things about Twitter. Okay, so now you see, because I made the things a little bit wider, I have Izimi RESTCorp 2. So I have like hashtags that are appearing more than once now. So here we go, hashtag UR. Does anyone know what this is? It's been very popular this morning too.
What UR?
UR. So if people have Twitter, we can just tweet now and see what happens. We should catch it, right? We can all say, I don't know, browse is awesome.
The windows are like 0. What's happening?
Sorry?
There are no hashtags and so on the windows, like 0.
There are no hashtags.
Yeah, it's like 0. I don't get any in Windows 0 and 1.
In your run.
Yeah.
Usually, the first couple windows will be empty, right? Because it's setting up and you're asking for 5 seconds. So usually the first window will be empty, right? That happened last time as well. But it should pick up from 2 or 3. Yeah. So this is the other thing, right? It's not like totally live near real-time streaming. Like I said, it's more the order of seconds. Okay, so that's that. So while that's sort of finishing up, let's look at this. So I wanted to brainstorm a bit on what one could do with this type of streaming capability. Right? I mean, you've just seen snippets of what you could do. So currently, marketing is a big thing. So people like to, there's like marketing outfits will go and evaluate based on various experiments in Twitter, how a particular product is selling, for example, um, um, and there's this other area, pharmaceutical vigilance. Someone who was at the Big Data Meetup, who works at the Uppsala Monitoring Center downtown. So they were interested in this at one point. So if a drug company releases a new drug and they want to kind of keep an eye on Twitter, people having adverse side effects or complaining about the drug, for example. So that's sort of being vigilant about some new drug releases. But that, of course, has a application. I mean, there are actually companies that specialize on reporting live to various mass media channels, like big TV channels. They'll be maybe watching a show like Star Trek. It released on Netflix. Does anyone watch the 4 episodes? Nobody? Okay. Anyway, the Star Trek Discovery, right? It's on Netflix, and it'll be interesting to know what people are talking about it. So usually when the show releases, you can sort of watch what's happening in social media. So there is, that's again another well-established commercial activity. So of course, because the news channels want to know what's really happening in social media, what is more popular, what shows you can. And of course, you could do all of this in Facebook, but you have to buy all of the data from Facebook. It's not free like this. You can scrape Facebook's wall and things like this. Anything publicly available, you can scrape it, but it's not like plugging into the fire hose, at least at some percentage. And if you want all the data on Twitter, of course, you have to buy it as well. Okay, what else? So reduce by key and window is a nice example. There are lots of other things you could do. For example, instead of just looking at hashtags, you could do this. This is another standard method, frequent pattern mining. This is right out of the box, like all the algorithms we're studying here. This is essentially trying to find frequently co-occurring patterns in data. So it could be maybe some hashtag co-occurs with some URL often, and you're sort of interested in that possibility. So, for example, you could take the entire tweet and then just apply, maybe find the top 10 hashtag containing tweets, and then maybe do some kind of frequent pattern mining to see what co-occurs. This is quite a nice thing to do. This has got some interesting things with association rule mining, and it's quite a nice thing to throw at data you have no idea about. And the classic examples here are, in big malls, they try that you can do frequent pattern mining, and then figure out from what people buy in a grocery store. And then, the standard story is that when fathers go shopping, at least in America, they buy beer and diapers. So they put diapers next to the beers, they sell more. I don't know how true it is, but this is in all these textbooks. So that's again like a placement problem for better sales, right? And it just, you're just mining frequently co-bought items. So again, streaming k-means is very, very nice. So this is again very, very powerful. So you saw k-means, but now just imagine doing k-means on a big batch streaming at you, right? So you'll have your cluster centers, and then the cluster centers themselves will start moving with the streams. So that's what this thing should be. So it's trying to show here. Let me see. So here's your centroids, and your cluster centers are themselves moving, because points are now coming in batches and can do this efficiently with the streaming k-means algorithm. Yeah, there's a lot of, so this is what's happening, you see. Over time, these black dots are your sort of cluster centers. They are sort of moving. So if you have like a time-varying phenomena that you want to cluster, then streaming k-means is sort of. Let's just do a live search and find if. So I told you last time someone was saying, oh, Barcelona traffic spark. Let's see if we find something. Maybe we won't get. So this is a really nice talk I saw a while back. Yeah, I'll buried somewhere. Anyway, so I think they were doing streaming k-means on Barcelona's anti-traffic with code trajectories and so on. Okay, so what kind of things could you do by you know, using streaming k-means on words or tweets? Okay, so let me open this. So this is actually a Git book from Databricks where they do a Twitter streaming language classifier. I won't play this video, but you guys should be able to figure this out now. You know pretty much all the basics to go and understand this, I think, right? So, so here's this a Git book. Let's see, starts. Hopefully our own material will be a book like this. So they're basically scraping data, cleaning it up, building a model, and doing classification. So Spark streaming is used to collect data. This will be quite similar to what we did. So let's just take a look quickly. So I'm hoping someone will, do a project or just come up here and present something, the next lecture. So let's check it out. So here is they're using a create stream from Twitter utils, which is basically, you can use extended Twitter utils, our old one. Yeah, and this should be identical. So they're doing Google JSON, so mapping all the tweets to JSON. We did this as well, right? So this line should be clear. And then for each RDD, they have this loop. And what's happening in here, they're just counting, outputting the RDD, they're repartitioning into whatever, say 1. They're just saving the text files exactly the same, right? Milliseconds to string, right? Okay, so just incrementing the counts. And yeah, so this is exactly what we did in our collector. Now, what is all this? Okay, so they're doing this in the sort of proper way, which is to write jars using Scala and SBT, Scala build tools, and this more data engineering, proper software engineering way. But you can just play with notebooks now. Now, what is the next thing they're doing? So let's go to the next page. Examine tweets and train a model. So using Spark SQL to get data, and then they're going to train the model with MLlib, and they're applying k-means algorithm for clustering the tweets. How the hell are they using k-means to cluster the tweets? Right? K-means algorithm needs points in symmetric space, right? And needs to have a distance, a metric, right? So you have to somehow go from words or tweets to points in symmetric space. So once you can do that, then you can apply k-means.
Sorry, but k-means algorithm works as well with categorical means, right? I mean, it's
yeah. Yeah, so yeah, I mean, k-means algorithm at the core level needs a metric, right? It means needs distances to be defined between points, and those distances have to be metric, right? So yeah, we have to do something to go from words to 0.834 is the distance between two words or whatever, right? So they will, I mean, there's a standard way to do this in NLP, and I actually forgot what it is. See here for the command to run part 2. Maybe we'll continue with this. Okay, so they're just doing SQL here. So maybe, oh, today apparently we don't have coffee, we have tea. Okay, so let's see. So JSON, registering a temp table, SQL, selecting the text from the tweet table, just 10 of them. What else is going on? Okay, not much. They're just checking out the data. I think this is the main thing we wanted. Covers how to train a language class for the text in the tweets. First, we need to featureize the tweet text. MLlib has hashing TF class. Hashing TF. I guess that's term frequency, hashing term frequency. Okay, so what is this? Create a feature vector by turning each tweet into bigrams of characters. So bigrams are 2 consecutive words, I think. Huh?
They are doing characters.
Oh yeah, bigrams of characters, good. This is characters. And then hashing those to a length 1000 feature vector that we can pass to MLlib. Okay, so once they get bigrams to consecutive characters, and I guess they will do the counts first, right? And then hash that to a length 1000 feature vector. So that means they somehow have a cutoff of 1000, right?
They are taking top 1000 bigrams.
Yeah, the most frequent counts. Yeah. So I think, yeah, he's an NLP guy. Are there other NLP guys here?
Some.
No?
A little.
A little? Okay. I just try to do whatever I understand, but I know a little up to now. But NLP is very, very deep subject. There's a lot going on. But once you do this, then you're done, right? You're already in a metric space. You know, feature vectors are sitting in some high dimensional space. You can look at Euclidean norm or whatever is the standard you want to do. So and this is it, I guess. So featureize is this just TF, hashing TF, term frequency transform, and okay, so here's k-means. This is similar to what we had. Yeah. Okay, so who wants to try this? Chain it to the. I mean, you can even do it naively, right? You can just collect the stuff in the Twitter and try this. So this is not the streaming version. So there's a, if you just read the other notebook, it'll be nice to come up with a streaming k-means version. And I think Mariama, she was interested in she's not here today, but she was interested in maybe, finding some kind of I don't know, something that will assist you to read stuff. So if you have lots and lots of tweets, maybe you can do some kind of a k-means or maybe even a streaming k-means, and then it'll help you sort of cluster tweets of a similar type together, maybe. Okay, so what else are they doing? Yeah.
So in order to do this k-means on words, the words somehow have to be converted in some feature vector of numbers.
Yes. Yes. So what these guys, I think, are doing is they basically look at consecutive pairs of characters in the tweet, because tweet is quite small. So every consecutive pair comes in a tweet, and then they simply count the numbers, how many times. So that's a bigram. So basically a tweet becomes a bigram, histogram consecutive characters. And then they have a maximum of 1,000 bigrams they allow. So I think they should be taking the most frequent bigrams in your collection.
So this is different from this word to web technique.
Isn't that the same?
What I understand, word to vec is like it will give the synonym, like if there is a one word, then you can get lots of a cluster with a similar word in a vector space. For example, like on the context of the text. For example, if someone is talking about election, like let's say about drugs, if I want to find the new name of the drug, like weed, they might have a different name for the weed now. But then what it does, like it might find the synonym of weed by looking the context, like how it appears in the text. But here what they are doing, I think, is like, okay, they have a text, but you cannot represent that in a some vector space text. Like to do gaming, you need to have some distance between 2 points. Then they are converting that text into some vector space. Like they will count how many times the characters appears in the text, just to change into vector space to find the distance between two vectors.
Yeah, I mean, I think this will be a good homework, right? So maybe someone can. I'll do it if nobody does, but if someone does it, it'll be good to maybe. I think it'll be good for you. You could even not even forget about Twitter and continue with this with your, your Russian text thing you were doing. I mean, just if you want. So anyway, I kind of am trying to do the notes now, like branching process. So I'm going to take you down a hole. It's like, hey, look, go see. I mean, so we want to make sure you can start doing stuff. Okay. Yeah, and this one we might come back to this. This is a very powerful technique. So we'll probably come back to this after the break. So this is latent Dirichlet allocation. It's a very nice way of finding topics. So people in digital humanities, all sorts of natural language processing consumers, they like this method. And it allows you to do what's called topic modeling. So you can kind of do clustering of documents, for example. Or even you could even apply this to tweets and see what happens. Although tweets are quite short, so it'll be tricky. Okay, so I'll quickly tell you in the next 2 minutes what is in store. So I thought we could spend maybe a little bit of time discussing about how one could design experiments in Twitter, more than just having a streaming API just spit stuff at you. But what you would really want is to, look at the streaming jobs, do some ETL, some SQL, and get some insights. Maybe you find some accounts that are interesting or whatever, or some hashtags that are interesting, and you want to, change your collector, right? So if you want to add more hashtags, you can already do that. You can just go back to your streaming job, add a few more hashtags or whatever of interest to your tracked list, right? The list that's tracking the strings. So then it'll start collecting those hashtags as well. So your Twitter collection will, basically can be re-zoomed into what you want. The other thing you could do in parallel is, maybe you find some guys that are interesting, some accounts are interesting. What you can use is the REST API to query Twitter. So this is not the streaming API. This is this other whole world. Then the stuff he's worried about will happen. You need to make sure you're making the queries at the right rate. You don't make more than 3,200 queries every 15 minutes. It depends on what REST call you're making. And these REST calls could be something very nice, very simple, like give me the entire history that I can freely get for this user of interest, right? And this could be, 3,200. Usually it's 3,200. Maybe it's changed now. status updates into the history of that user. So for Trump, that basically goes to like several months. He's very active in Twitter, but you can even get like almost a year of Trump's activity for free by doing this. So now you can imagine what you can do, right? You can take some people, some accounts, and then use the REST API relatively slowly, but still get thousands every couple hours. You can get their full histories, right? And the full histories means all the details of every status update. What was the original tweet, retweet, reply tweet, quote, whatever you want. And then you can basically bring that in to decide how you want to proceed further, right? So you could, for example, find all the people that retweeted some people of interest to you, maybe some politicians or some extremists or whatever, some marketing people, I have no idea, some products. And then you can ask, who else did they retweet? So you can, again, recursively go, it's like a breadth first expansion on the retweet network, that goes into the past now, right? And so that'll give you a lot more context, so you can start doing a lot more. So is anyone interested in this kind of a little bit into REST? Should I fill this notebook, or I can just always put the API docs here. But if anyone is interested in doing some kind of Twitter-ish project, then you probably want to use REST in combination with streams, not just streams. And if no one is interested in Twitter for a project, then I will just put the URL to the REST API. Okay, so maybe let's have Fika and continue.